Let's look at two other linear examples. The cost of leasing a car is $800 for a down payment and processing fee, plus $240 a month. So we know that this is an actual increase of $240 per month, and we're adding that in. So we want to write a linear equation. So we're talking about the cost. So C equals, the initial amount is $800. Since it's increasing, we're going to increase, so it's plus $240, and it's happening each month, so the letter M. So that's our equation, and making sure that we use variables that make sense, so C and M. So how many months can you lease a car with $3,680? So we know that we can spend $3,680. That's equal to our equation. We got to take out 800 off the top, so we're going to subtract that 800, and so we get 2880 equals 240M. And what we did is we just subtracted 800. And now we want to divide this up equally to figure out how many months this is going to happen. So M equals 12, and we did that by dividing by 240. So our answer is going to be 12 months. All right, when we look at another problem, this time, so in question number 4 here, we were given the initial value and we were given the rate. Okay, in this next problem, in number 5, the maximum speed of a semi-trailer truck driving up a steep hill depends on the weight of the cargo. All right, so we have this depends on, so that is going to tell us that the weight is driving the speed. So the speed, in this case the max speed, is dependent on the weight. So we know that the weight is our input and our speed is our output. All right, so with 10 tons of cargo, the truck can maintain a max speed of 45 miles per hour. With 50 tons of cargo, its max speed decreases and can only go 25 miles per hour. So why is this situation a function? And if we recall, a function is each input has its own output. So this is a function because for every weight on the truck, there is only one max speed. All right, so now we have two ordered pairs. Remember, an ordered pair is an input and an output. And so we know that our input is the weight. So we have 10 tons of cargo and we have 50 tons of cargo. So we have 10 comma and then 50 comma. And 10 tons of cargo is associated with a max speed of 45 miles per hour. And 50-ton cargo is a max speed of 25 miles per hour. So we have 10 comma 45. And we have 50 comma 25. All right, so now we want to calculate that rate of change. So again, the rate of change is the change in the outputs. So again, the order makes no difference as long as you go in the same order. So 45 minus 25 divided by the change. So change is to subtract again. And we end up with 20 over negative 40, which simplifies to a negative 0.5 miles per hour per 1 ton. Right, so that means that the truck will, every time you put a ton of weight on the truck's speed decreases by half a mile per hour. This is the same thing as our gas price problem when we were decreasing, for every cent that we added to the price, we decreased by 120 gallons. So this is saying for every ton we put on the truck, we're decreasing its speed by half a mile per hour. So we want to find the initial speed. So the initial speed would be if the weight is 0 pounds or 0 tons is our initial speed. So right now we know that 10 tons, we know something about 10 tons. We want to get it to 0 tons. So that means we need to decrease by 10 tons. So just as we did with our gas price problem, we're going to take negative 10 tons times our rate, which is negative 0.5 tons, or sorry, negative 0.5 miles per hour, or 1 ton. And when we multiply those together, we will end up with 5 miles per hour faster. So the truck is going to go 5 miles per hour faster if we increase, or if we take off those 10 tons. All right, so what is our initial speed? If it was going 45 miles per hour, then our speed, if we take off those 10 tons, our speed is going to be 5 miles per hour faster. So instead of 45 miles per hour, our speed is going to be 50 miles per hour. So now we know that the speed is equal to the initial speed of 50 minus 0.5 for every ton or every bit of weight that you put on the truck.